I'm sorry. This conference just loves video effects. I've got to do it. All right. So today we're going to talk about loading on the web. Loading is a user journey with very disparate expectations. You're basically sending thousands and thousands of bytes down the wire and hoping that whatever comes out from the very end of that is something that's actually useful to your users and helps them interact with your applications relatively quickly. So I thought that today we'd have a conversation about loading. Now, we can't really have a conversation about loading without talking about where we're at right now. So this is what the average web page on mobile looks like in 2017. Whether it's built with sort of a JavaScript framework or just a static site in many cases. It takes 16 seconds to get interactive on a real mobile device on 3G. Usually takes 19 seconds to be fully loaded. And people mostly send somewhere in the region of 420, 450 kilobytes of JavaScript down the wire. Now, why does any of this actually matter? Well, if we take a look at a high level at how the browser actually manages to get anything rendered to the screen from the network, it's a relatively simple process. We send a request out, the server returns some HTML, we go and we parse the CSS and JavaScript and images and anything else that comes back, and then we actually have to parse, compile, and render that code in order to render it and turn it onto pixels on the screen, right? But it's never quite that simple. We're usually developing on relatively powerful, high-end desktop machines. And the expectations that we have when we're profiling there are quite different to mobile. In particular, when it comes to things like JavaScript startup performance, where on a real-world mobile device, you can end up seeing anywhere between 4 and 5 times of a slowdown. So the first thing I think that we as a community need to shift towards doing is actually testing on real phones and real networks. I know there are a bunch of people. So how many people here actually use like the DevTools network emulation or CPU throttling or device mode? So a lot of people here. That's great. That's a great first step. We need to do better than that, though, because mobile devices have got different GPUs, different CPUs, different memory, different battery characteristics. So there's a lot that we can do there. For people that want to start doing that today, we recently shipped a new part of webpagetest.org. Called /easy. So webpagetest.org/easy has got a whole farm of average mobile devices on there right now with easy profiles for going and checking out your performance. Now, a lot of the time when we talk about mobile performance these days, we reference this idea of time to interactive. And the idea there is that you're just able to make sure that the user can actually tap around your interface and have something useful actually happen. In this case, I think that someone is going through like a withdrawal symptom because there isn't actually anything on their phone. It looks a little bit dead. So there are a few rules that I like to follow when I'm building modern web apps that try to load efficiently. The first is only load what you need. So try to make sure that if you're shipping script and CSS and everything else down the wire, that it's only the things that are going to actually be useful to the user's initial experience, and that you're using idle time to load in anything else, so your comment threads, any additional pages that might be needed for the rest of the user experience. Now, there are a lot of things that we can do to actually help load less code. One of the first things is code splitting. So code splitting is something that a lot of you probably are familiar with as a concept. Relatively straightforward to get set up using Webpack or Splittable or Clojure Compiler or Browserify. The basic idea is that instead of like making your user eat an entire pizza and get really bloated, you just give them a single piece at a time. And that way, hopefully, they feel a little bit better about the experience that you're shipping down. Tree shaking, so removing unused exports, using things like rollup, also worth spending time on. Something we don't talk about enough is the fact that the baselines we're using when we're trying to ship powerful experiences on mobile don't always set us up for success today. So if a framework, for example, and I love frameworks. I created StuMVC, I love frameworks. I use like React and Vue and Preact all the time. But the frameworks that we use today are often built with desktop machines in mind. And when it comes to actually trying them out on mobile, if we're saying you've got to be interactive in like 5 seconds, and your framework is eating up like 4 seconds of that in its boot up time, that's not setting you up for success. So there's probably room that we've got to improve there. There are lots of lightweight options today, Preact, Vue, Svelte, Polymer. There are lots of others that generally have a relatively low parse and startup time. Over on the DevTools side, one of the things that we recently shipped to help you with this idea of shipping less code is a feature called code coverage. The idea here is that you just load up your app, You hit record in this new item in the drawer, and then we tell you what blocks of code actually got executed and which ones didn't. So here we've got sort of an indication that maybe I'm not really using 50% of the code in the bundle that I'm shipping down. And as we click on that and scroll through the sources panel, you can see that we highlight in green code that got executed and red code that didn't. In this case, because this is a camera app, I've got a lot of code for actually doing cross-browser saving of files and export, which I can probably be lazily loading in. Other things we can do, like most of us here are probably using a transpiler of some sort to use all the juicy new features JavaScript has got. But the reality is that cross-browser ES 2015 support is in a relatively good place right now. We don't always need to be sending people down ES5. So if you're shipping an experience using Babel today, I strongly encourage you to try out Babel preset env. This will basically only transpile code for the browsers that need it, and just keep everything else in ES 2015. Let's check that out. If you happen to be using Lodash, check out Babel plugin Lodash. This is sort of a neat transform that will rewrite your Lodash code so that it only uses the modules that you're actually using in your source rather than the entire package. So check that out too. This week we also announced, after a very long wait, support for ES 2015 modules in Chrome. Thank you. This is something that will hopefully encourage, again, a little bit less transpilation, and is something that will open up a few more opportunities for interesting loading experiences across the board. The next thing I like to do is order loading thoughtfully. You know more than anybody else in the stack, what is important to your user journey, and what needs to be sent down earlier on than anything else. Something that we recently also shipped in DevTools to help with this is a feature called network request blocking that's in Canary right now. The idea here is that in the network waterfall for any site, you can right-click on a network request, and you can block it, or you can block the domain, and take a look at what impact that has on the overall critical path for your site. Particularly useful if you've got a lot of third-party code that's slowing you down. And finally, cache aggressively and granularly. Cache as much as you can locally. That's both with the HTTP cache, but also using service worker caching. At Google, we've been trying to ramp up our investment in service worker for a lot of our flagship apps. Inbox has been using service worker quite a lot, and recently saw a 10% improvement in time to interactive just by making sure that they're using it for things like static resource caching. Now, about 3 years ago, I was speaking at JSConf, and we spent the whole talk sort of optimizing JSConf.eu. And I thought, given that I'm back here, it'd be kind of fun to do that again at a much shorter rate, but also a little bit maybe unorthodoxly. So what we're going to do is we're going to hack Chrome to make JSConf.eu load a little bit faster. This guy is not, in fact, a hacker. He's just like scrolling through his Webpack config or something. So you dive into C++ in Chrome, and you find this file called resource fetcher. And resource fetcher is one of these files. I know nobody can see this, so let's just zoom in here. This is one of these files that define how Chrome actually handles the prioritization for different types of resources. So your CSS, your JavaScript, your images. I don't expect anybody to read this. So here's a table of how we actually handle this. Layout blocking resources like CSS and fonts get the highest priority. Load in layout blocking phase resources like scripts or images that happen to be in the viewport get a medium priority. And then everything from your async scripts to images that are outside of the viewport, mismatched CSS, they get a much, much lower priority. What's interesting about this table, actually, is that images in your viewport get a medium priority, and stuff that's outside of it get a lower one. So we kind of do automatic lazy loading of images to some extent by default. Now that's great, but as a developer, you probably care more about where this is exposed for you. So in the network panel, there's a column called priority that will tell you exactly what priority was used for any of the resources that you wanted to load. So we're back here, and the part of Chrome that we're going to hack is we're actually going to change absolutely every single type of resource to load with an extremely high priority. Sounds like a great idea, right? So let's do that. And that's going to fix all of our problems, and I can just end the talk there, right? We could ship a new browser. We could call it, so I discovered Germany has got this wonderful world called Verschlimmenbezern, which, that's a terrible pronunciation, but it means when you try to fix something, but you actually made it a whole lot worse. And I did. So this is the original film strip for JSConf EU, and this is what it looks like when everything is considered high priority. We've actually completely shifted first meaningful paint way back. Performance is worse. The lesson there, when everything is high priority, nothing is. And I ended up fixing this by going through the different types of resources that are used in this particular page and trying to figure out, OK, well, are the images the most important thing? Is it the CSS? And as it turns out, it was the CSS and fonts. So let's do this right by the browser. We talked already about sort of at the high level how network requests work. But there's a piece of this puzzle that I didn't quite dive into, and that's the browser preload scanner. Now, browsers like Chrome have got a document parser. And as we go through the tokenization phase of actually reading through all the different tokens that compose your HTML, we will go and try to fetch those resources and start processing them. If we run into like a blocking script, that's going to stop the document parser in its tracks, which is why we have this sort of fallback thing, the preload scanner, which is able to look ahead even when the document parser is blocked and find other resources that we can continue to fetch and process. When this change was first introduced in Chrome, I believe it introduced like a 20% improvement to overall load time, so the preload scanner is pretty cool. But we run into this other interesting challenge, which is discovery. No browser knows exactly what sequence of things to load to make sure that your page is going to be fast. You, more than anybody else, again, know what's important in your page, whether it's your Webpack bundles that needs to be loaded early on or something else. And so to address discoverability and the ability for you as an author to be able to say what you consider to be high priority, you can use things like link-rel preload, which works with scripts and style sheets and other types of resources, and is basically a declarative fetch that tells the browser that you consider something to be high priority. Now, this is what the impact of using it on a site that happens to be using Webpack looks like. You kind of shift all of the yellow that's on the right all the way to the left at parse time. I'm seeing this pattern being used increasingly in progressive web apps where it's having a positive impact on time to interactive for a lot of folks. So I checked that out. If you're interested in actually hooking this up to your build process today, I wrote a Webpack plugin called Preload Webpack Plugin that can do this for asynchronous chunks as well as like normal chunks. So check it out if you find it interesting. Over on Chrome, the Polymer team worked on an app a while ago called Shop. And the idea behind Shop was trying to see, if we use the web platform and the web platform features that are available to us today, just how fast can we make a modern web experience that was sort of non-trivial. And Shop kind of checked that off. It was able to reach sort of granular loading. You're able to tap on things, and everything is just really nice and buttery smooth on mobile. But how did they accomplish this? So they used a pattern we came up with about last year called Purple. And the idea with Purple is that you try to make sure that you're sending down the most important things for the user as early on as possible. You push the minimal code needed for a route. You render that route. For next routes, you're able to pre-cache anything using service worker so that not only is that stuff already available locally in the disk cache when they try navigating to it, but it's constantly available on repeat visits. In addition, for JavaScript, using service worker will actually early on opt you into V8's code cache, which will save you a little bit of time on things like parsing compilation. And then the pattern suggests lazy loading code that you need for other parts of your user experience. So let's take a look at what that actually looks like. So this is Shop before any optimizations were applied. You see sort of this step pattern in the timeline. So this is HTTP2 with 3G. And remember that little block at the very start where we're not actually seeing any activity. We're going to go back to that a little bit later. With preload, we actually changed the shape of that completely. So we've gone from this to something that looks like this. Basically, we've shifted our time a little bit. Everything is now going to be attempting to load in parallel to some extent. And that starts shaving off some time over the overall user experience. But it still comes at the cost of multiple round trips. And this is where things like HTTP2 server push can actually come in useful. Now, what push allows us to do is, as an author, specify, using a manifest, the files that we know are going to be critical to the user journey. Instead of just pushing down the request, sending the browser some HTML, which then needs to be parsed, when we send back that initial HTML, we can also start sending down a list of files that are super important to start fetching for the experience. Effectively, we're filling up server think time, where today, in a lot of cases, we're not actually doing that. So HTTP2 server push is great for that. And the impact that it had on this particular app was quite stark. Again, we've shaved thousands of milliseconds off of the overall time for this app to get interactive and to load in general using this technique. Unfortunately, HTTP2 server push is not a silver bullet by any means. It's not particularly cache aware. In a perfect world, we'd have the ability to have a cache digest or something that lets you know what exactly is in your user cache. And so it's very easy to run into cases where, every single time someone comes to your site, you're just force pushing them, the same set of files, even if it's inside their cache, which is not exactly ideal. So push versus preload, push can cut out a whole RTT. It's not cache aware. There's no real prioritization in place. Preload is particularly useful because in addition to what push can do, it also supports cross-origin requests. It's got load and error events. It's got content negotiation. But how do we address this issue of H2 push not particularly knowing what's in the cache? Well, we can use service worker. If we have a service worker registered in such a way that instead of going to the network every single time that we need more resources to be fetched, we're just trying to get them locally based on what is already cached, we avoid this issue of needing cache digests. And it makes this entire setup relatively sane. For shop in particular, this meant that on repeat visits, once you tie absolutely everything in purple together, you're actually able to boot up and get interactive in just a few hundred milliseconds. It's quite a powerful pattern. So preload is good for moving the start download time of an asset closer to the initial request, and push is good for cutting out a full RTT if you have a service worker. Thanks to Sam Ciccone for a bunch of the research that he did in this area. The next thing I want to talk about is how a lot of this stuff can apply to the apps that you're probably building today. Out of interest, how many people here are using React as a part of their default stack? Almost everybody, or good size of the audience. So I had the privilege of being able to work with Twitter on their new progressive web app, Twitter Lite. And I wanted to talk a little bit about the learnings that we had there. So Twitter started off with this, which was their old mobile web experience. It was sort of the server-side rendered thing. It was really, really slow. And it wasn't particularly happy. Didn't particularly encourage users to get engaging with the app. This is the new progressive web app that Twitter shipped very, very recently. This is Twitter Lite. And one of the accomplishments that they had by taking advantage of some of the primitives that we just talked about is that they were able to get interactive in under 5 seconds on 3G, which is quite a nice feat. Now, this didn't come without an amount of pain. So you can use modern frameworks like React to ship progressive web apps, but you're going to have to put the work in to cut down on how much application code you've got going on there. You're going to have to take advantage of code splitting. You're going to have to make sure that you're just granularly loading and serving things in as well as you can. So when Twitter first started working on this app early on, they had a relatively poor time to interactive score. So they were looking at about 15, 16 milliseconds before anyone could actually start tapping around the interface. So not too far away from where a lot of us probably are today. Most of their critical path was dominated by time spent in script just booting up. And so they started taking a look at patterns like purple and how they could take advantage of them. The first thing they introduced was support for DNS prefetch, so the ability to just specify declaratively what servers you want to start warming your DNS connections up to. That led to an 18% performance improvement on what they initially had, just for at least hitting things like FMP. Next, they investigated using Preload for their critical scripts. I can't tell you how easy this stuff is to set up. Like, this will take you, if you're using a static site, it's probably less than 10 minutes. If you're using something full stack, it will probably take you an hour. But it's worth trying out just to see if it actually has a perceivable improvement on your site. So they ended up preloading their critical scripts. So this is like their vendor bundle, their asynchronous scripts, as well as their main scripts. That led to a 36% improvement on their overall time to interactive. Next, they put work into actually putting pixels on the screen much faster. Now, Twitter is one of those experiences that are very, media rich. There's a lot of images in there. And so it's unsurprising that media and images were one of the things that were slowing them down render-wise. Now, one of the things they did was they used request idle callback to actually defer loading of some of the images in their timeline, and that led to a 4 times improvement on their render performance. RIC is kind of awesome, definitely worth exploring. Another thing that they noticed was, and this is kind of, it's so silly, but images are still such a big part of what slows us down these days. They noticed that they were still sending down relatively large images that were not the right height or width, that were still encoded, suboptimally, and were taking a long time to decode as soon as they hit Chrome. They went through the process of actually optimizing that, and that shaved off a whole lot of time on their image decodes. Helped them to make sure that as you scroll through the timeline, images are at least not one of those things that are causing you a bottleneck. Another thing that they introduced was data saver mode. This is this idea that you as a user can say, well, I've got a limited data plan. I just want you to not show any images or videos unless I actually tap on them. And this led to a 70% improvement in many cases on the amount of data consumed by the application. If you're looking at a web platform level at what we're doing to try helping enable these types of experiences, we've got the save data client hint that you can use, and Twitter are going to investigate using that next. Then you've got pre-cache. So initially, Twitter Lite didn't have support for anything offline or service worker caching. And what they did was they incrementally took an approach to adopting service worker. They started off by, first of all, statically sort of caching their scripts, the emoji that are used whenever you try DMing someone or replying to tweets, as well as CSS. And then they ramped that up over time to include things like application shell caching, so UI caching. Now, what that did on repeat visits was it took load time down from 6.10 seconds down to 1.49 seconds. So when you, after the first time that you visit Twitter Lite, it feels instant coming back and trying to navigate across different views. It's pretty powerful. Now, I was cheeky and asked Twitter to host 20 different versions of their site so I could go and profile them, and they were kind enough to do that. Now, on second load without a service worker, after some of these changes, they saw that they were 47% faster. On second load, so repeat visits with a service worker, they were 65% faster. Then you've got lazy load. So remember when we were looking, so this is a Lighthouse report, if I didn't mention it before. Remember when we were saying earlier that their time to interactive scores kind of sucked and needed a little bit of work? Well, breaking that work up was one of the first things they needed to do. So they had sort of these large blocks of monolithic JavaScript bundles that I know people are some people are just, oh, don't look at me, I'm not doing that. But a lot of people actually still do this. And that's relatively slow to load on mobile. If you have a relatively large bundle, even if you think that a few hundred kilobytes isn't a lot, that's still extra work the browser has to do to parse and compile that code before it can even start to boot it up. So initially, their bundles were taking 5.5 seconds-ish, to get ready before code splitting. And then they had this great moment where they were trying to figure out how you're supposed to configure Webpack, and are still having the best of times with it. I hear it's gotten better with Webpack 2. We'll see. And one of the things that they ended up doing was, this is a lot of what their code splitting looks like beyond just using require.ensure. They're just making sure that they're correctly using sort of vendor splitting for all of their bundles across different views. Twitter ended up creating something like 40 different asynchronous chunks that are granularly loaded as you navigate from one view to the other. And the impact that had on their experience was that actual bundle ended up only taking about 3 seconds to fully process. And it improved their overall time to interactive. By the end of it, they're actually doing much better than this now, but by the end of it, they were getting interactive in about 5.7 seconds, which is still impressive as an investment in just code splitting and some relatively low friction ideas around efficient loading. So one other thing that they ended up finding was incredibly invaluable and have been coming back to it pretty regularly is just making sure that they're using bundle analyzers like Webpack Bundle Analyzer to find out what low-hanging fruit they have in their bundles. I keep running into people that don't realize that Moment.js or other libraries are actually a big part of their bundles and can probably be trimmed down. So if you're not using things like Webpack Bundle Analyzer or Source Map Explorer, do check them out. They do generally lead to at least understanding a little bit more about what it is you're sending down the wire. And in Twitter's case, they were making sure that they were using the Bundle Analyzer plugin so that every single time someone was actually working directly on the application, they could see what impact that ended up having on their bundle size, on their actual bundle shape. So performance is sort of this continuous game of measuring for areas to improve. There isn't a single thing that you can do and then just leave it, where your site is going to always be fast, regardless of the devices that your users end up trying it out on. For anyone that is interested in sort of getting involved with more continuous performance profiling, where your team are staying on top of it and you're building up a performance culture, I'm happy to encourage you trying out Lighthouse. It's one of the projects that we work on. Lighthouse sort of is an auditing tool for both performance metrics, but also progressive web app features and general web platform best practices. And I'm also happy to suggest trying out Calibre by Ben Schwartz. Calibre is sort of great in that it allows you over time to track everything from your bundle size through to different performance metrics and see what impact your different deploys had over time. So check that out. And I'd also encourage people to check out web page test integration with your Git hooks. Housing.com is a progressive web app that did this. And basically, they have this really awesome setup where anytime someone tries to submit a new PR for a feature, it runs it through web page test and will include a film strip at the very bottom of your PR to show exactly what impact that had on the user experience. So with that, I hope you found this little journey into loading useful. I hope you found the story about some of the experiences we had with Twitter useful. I know that Twitter is great. It also sometimes feels like group therapy where no one ever gets any better. But it's great. So yeah, if you're interested in learning a little bit more about loading, we started a new blog over on the Chrome team called Reloading on Medium, so medium.com/reloading. And we intend on publishing more material there over the next coming months about everything from H2 server push through to Brotli, Gretzli, and a lot of the other work that we're doing in the loading space. And that's it for me. Thank you.